Welcome viewers, in this video we will see the realization of Boolean function using the decoder. Example 1. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. The problem is we need to realize the Boolean function using the decoder. The problem statement is implement Boolean function f equal to sum of min term 1, 2, 3, 7 using the 3:8 decoder. By using 3:8 decoder, we need to implement this Boolean function. We know that decoder is a device having n input and 2 to the power n output. Here 3 inputs are available, 2 to the power 3, that is 8 outputs are available. So up to 7 is there. So definitely we need 8 different outputs, 3 digits with 8 different outputs, right? The step 1 is connect function variable as input to the decoder. The second one, logically OR the outputs corresponding to the present min terms to obtain the output. This is sum of min term. So we are using OR gate at the output. Input side we are connected the required input variables. Output we are connecting the OR gate to get the sum of min term. This is sum of min term. We need to add this min term 1, 2, 3, 7. Right. Now we'll see the logic diagram. So this is the 3 to 8 decoder. 3 inputs A, B, C and 8 different outputs. This is enable input. 3 inputs are A, B, C. Right. So based on this A, B, C value, we'll get the 8 different outputs. Right. 3 digits, 8 possible combinations are available. For example, A, B, C may be 0, 0, 0. If all are 0, 0, we'll get the output high here 1. Other digits are 0. 0, 0, 1 means we'll get the high output here. Other digits are 0. 0, 1, 0 means we'll get the high output. Other digits are 0. 0, 1, 1 means we'll get the high output. Other digits are 0. So these 3 is the input and this is the output, right? The first 3 digit input, this is output. Then 1, 0, 0 we'll get the 1 as a high output. Then 1, 0, 1, then 1 as a high output. Other digits are 0. Then this is 1, 0, 0, 1. Then 1, 1, 0. We'll get 1 as a high output. Finally 1, 1, 1 means we'll get the high output, right? So based on the 3 digits A, B, C, there are 8 combinations available. 0, 0, 0, 0, 0, 1. 0, 0, 0 means this output will be higher. All other output will be low. Y1, 0, 0, 1 means Y1 will be higher. Other outputs are 0. So correspondingly what we'll get here, we'll get 0, 1, 2, 3, 4, 5, 6 and 7 as a output. So what we need in the given function is given as 1, 2, 3, 7. These 4 min terms. So we are connecting the corresponding outputs. Y1. So here we'll get 1 as the output. So Y1 is connected. Y2 is connected. Y3 is connected. Then Y4, Y5, Y6 is not needed. Then we connected Y7. Right? Y1, 2, 3, 7. These 4 inputs are connected. So this is sum of min term. This OR gate will add these min terms and give the output. The required Boolean function will be available at this output, right? So 3 inputs, based on the 3 input, the 8 combinations are there. The 8 possible outputs will be there, 0 to 7. What we need is 1, 2, 3, 7. So only 1, 2, 3 and 7 is connected. So this OR gate will add all these 4 inputs and give the required Boolean function. So in this video we discussed the implementation of Boolean function using the decoder. The input is connected, output, 8 possible output is available. What are the terms we need? That alone connected to OR gate and we'll get the required Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.